The question we are solving now belongs to test series 10. It is of network theory subject. In specific, it belongs to two-port networks. As per the question, there is a two-port network shown in the figure. The two-port network has the input as V1 and the input current as I1. It has the output voltage of V2 and the output current as I2 with directions as shown. And there are two impedances in the circuit. One of them is 2 at a phase of 30 degrees and other one is at 3 at a phase of 60 degrees. From this data, we need to find the ABCD parameters of the circuit. We know that the ABCD parameters of the circuit can be related by V1 V2 is equal to A B C D multiplied by I1 minus I2. From this, we can write the different equations or expressions for obtaining the ABCD parameters as A is equal to V1 by, sorry, this is I1, this is V2. A is equal to V1 by V2 when I2 is equal to 0. When the output terminals are open, A is equal to V1 by V2 and when I2 is equal to 0. Hence, when the output terminals are open, we can say that V1 is equal to V2, hence A is equal to 1. And we can say that B can be written as V1 by minus I2 when V2 is equal to 0. That is, when the output terminals are shorted, B can be written as V1 by minus I2. And in this case, we can say that V1 can be written as 3 at a phase of 60 degrees multiplied by I2. Therefore, V1 by I2 is equal to 3 at a phase of 60 degrees and hence B can be written as minus 1 multiplied by 3 at a phase of 60 degrees. Minus 1 can be written as 1 at a phase of 180 degrees, hence B can be simplified as 3 at a phase of 240 degrees. And finally, C can be written as I1 by V2 when I2 is equal to 0. That is, when the output terminals are open, C can be written as I1 by V2. So when the output terminals are open, we can say that V2 is equal to 2 at a phase of 30 degrees multiplied by I1. This is due to the reason that whole of the current I1 flows through the through this impedance. Hence, from this we can say that C is equal to 1 by 2 at a phase of 30 degrees, and upon simplification this is 0.5 multiplied by 0.5 at a phase of minus 30 degrees. Finally, we can write D is equal to I1 divided by minus I2 when V2 is equal to 0. That is, when the output terminals are shorted, D is equal to I1 divided by minus I2. And using the current divider rule, this can be written as minus of root 3 plus j divided by root 3 plus j plus 3 by 2 plus j root 3 by 2 or j 3 root 3 by 2. From this we can say that the D parameter out of the transmission parameters can be obtained as shown. Hence, for the given circuit, we got the ABCD parameters as shown, and out of the given option, the correct ABCD parameter corresponds to the option A, in which the parameter A is mentioned correctly. Hence, the correct option is A.